Ladies and gentlemen, please take your seats. Our program is about to begin. أيها السيدات والسادة، سيبدأ البرنامج بعد قليل، لذا نرجو منكم التكرم بالجلوس في مقاعدكم. Ladies and gentlemen, please take your seats. Our program is about to begin. أيها السيدات والسادة، سيبدأ البرنامج بعد قليل، لذا نرجو منكم التكرم بالجلوس في مقاعدكم.
Ladies and gentlemen, please silence your phones. Our program is about to begin.
Good afternoon, everybody. Hello, hi. My name is Ammar Abu Saoud. I'm a PhD candidate here at KAUST in Chemical Engineering, and it is my pleasure to welcome you all today to the very first distinguished lecture of WEP 2024, Emergency Location Service at Google by Dr. Mohammed Khider. He is the technical lead at Google's Android location and context team. Just a reminder, every day during the 2 weeks of WEP, we will be having lunchtime distinguished lectures, so we hope to see you all here every day. And for all the students, please make sure to register your attendance when you arrive to get the credits for this lecture. This session will be moderated by Dr. Tariq al-Nafouri, professor at the Electrical and Computer Engineering program at KAUST. Professor Tariq obtained his undergraduate degree from King Fahd University of Petroleum and Minerals, MS degree from Georgia Institute of Technology, and PhD degree from Stanford University, all in electrical engineering. He has been with KAUST since 2012. Professor Tariq's research interests are in wireless communications, smart health, and smart cities. Please join me in welcoming Professor Tariq al-Nafouri.
Thank you, Ammar, for the kind introduction. It's my pleasure to introduce our keynote speaker for today, Dr. Mohammed Khider. Dr. Khider is a technical lead and manager at Google's Android location and context team. So basically, he's part of the team that worked on improving your Google Maps. All of us probably use Google Maps. So specifically, his team works on improving the navigation and positioning accuracy of mobile devices in challenging indoor and outdoor environments. So if you use Google Maps again, he's the man to praise or blame. Before moving to the US, Dr. Khider was in Germany, where he obtained his PhD from Ulm University. He then was a research associate at the prestigious German Aerospace Center. There, at this German center, he worked on various research projects related to positioning, navigation, and context-aware computing. So in total, Dr. Khider has 16 years of experience in localization navigation, and so it's a pleasure to have him here. Please join me in welcoming Dr. Khider.
Thank you for the introduction, Professor Tariq, and thank you for inviting me here today. I'm excited and honored to discuss emergency location services at Google. The timing of this talk is truly remarkable. Why? Because last week we announced to the world the continued expansion of our service, which I'm very proud of, and I will talk about more in the next few slides. A common question when any of us call 911 or 999 or whatever the emergency number in your country is, where is your emergency? We all know that GPS works great outdoors. Many of us drive around, use GPS to go from one place to the other. But does any of you try to turn on their GPS receiver here indoor? Of course, not on Google Maps, because in Google Maps we use some tricks, or Apple Maps, to compute location indoor. Raise your hand if you are in a deep urban area with a lot of high buildings, and you order an Uber or a Lyft, and it arrives in the wrong side of the street. I'm sure many of you saw this in downtown areas. And that's the challenges of GPS. So how can we improve our location accuracies for our emergency responders to be able to find us during these emergency situations? In 2015, the National Emergency Number Association, which is a well-known organization in the US, did a study and found that only 20% of emergency phone calls are made with wired phones. And the remaining 80% are made with mobile phones. Actually, this is a pretty staggering number. And many of these 80% calls are made while the user or the people of emergency are deep indoor environments, where GPS is having problems. And this is the percentage, as I showed, 20% and 80%. So throughout this talk, I will splash some quotes for us to think about. Here is a quote by the American Heart Association, which says, "For every minute that you have a cardiac arrest, you are pulseless. Your chance of survival drops by 10%. So every minute delay for the ambulance reaching you, your probability of surviving drop by 10%. So let's start off with a short clip that highlight the issues that we are faced off today with our emergency 911 system or 999 system. And for this video, I would like to thank the Miami Police Department because they helped us preparing this video and allowed us to place test calls. So we're calling 911 and they know it's not a real emergency, just testing their system. During this video, you will see one of our team members dialing 911, and he will ask the emergency operator for our location, the location that sent to them while we call the 911. So let's watch the video and see what happened.
Hi, this is a Google test call. Can you please tell me the address on your screen?
800 Ringgold Avenue.
And can you repeat that one more time?
800 Ringgold Avenue.
Excellent. Thank you very much.
You see the line? The actual call was made across the bridge. The location that was sent from the phone to this center was many meters away. And actually, exactly, it was 500 meters away from the actual location. And 500 meters is actually a typical case for receiving cell tower location. Cell tower location is you can know, approximately, I can know where you are by knowing to which cell tower you are connected, because the telecom provider know the exact location of each cell tower. Good to tell you what is the weather, like they know that you are in coast and they tell you the weather is this much, but not good enough for emergency. So having position with this much uncertainty would render emergency responders helpless, and they might not be able to reach you. So in today's talk, I would like to cover the following. First, emergency location today. What is wrong with today's system? Second, we will go through how Google Emergency Location System, from now on, I will refer to it as ELS. So whenever you hear ELS, that's the Google Emergency Location Service that we built. Third, location accuracy challenge. Like we are building something, but still it has some challenges. And I would like to invite all of you doing research here to do more to make location better. Whoever doing research in location, like Professor Tariq's team. And finally, I would like to close with some discussion and conclusion. So emergency location today, what's wrong with this system? When dialing an emergency number from a landline, let's think this is a landline, this is not a mobile phone. Usually your telecom provider has an association between that landline and a physical address. When you go and fill your information, you provide a physical address. But as you will see, there is nothing automatic about this complex system. From the landline, so how do they know the location when you call from that landline? They are able to look up the phone number and associate it with the billing address, which then go to the service provider, like when you call 911, there is something called PSAP center. They send that location to the emergency or ambulance or the police, which then go to the selected router. There is a router algorithm. Based on that address, the telephone provider is able to route that call to the correct address or to the correct, and you will hear this term often, public safety answering point. And we call it PSAP. And this is the center normally. The location is sent to them, and they send it, depending on if you want an ambulance or a police or normally it's owned by government. It's a local civil authority number. And that's the picture of, like the picture you see here is how operators in this public safety answering point are working day to day. They get the call or they get the location, and they look to the accuracy of the location, and they send that location to the ambulance telling them, hey, this is the location, and by the way, the accuracy of that location is that much. Because, for example, if you tell the ambulance the address is this address, without telling them the accuracy, they might reach to the wrong address without knowing that they reached to the wrong address. So it's a kind of how much you trust that location. And of course, this PSAP center is able to dispatch police, fire, ambulance to the right place. But what if you did call the 911 from your phone, not from a landline? In that case, in today's system, the location of that is sent to this PSAP center is computed by your phone. They don't try to associate wherever. They say, okay, hey phone, give me your location. In most countries, the emergency system only relies on cell tower location to locate you. Cell tower location is very inaccurate. As I mentioned earlier, it's just telling them, I'm talking to this cell tower. The accuracy of the cell tower goes from meters to kilometers in size. So imagine you made a 911 call and the location is, for example, 12 kilometers. I will not know where in the campus you are. And this is what I mentioned. The cell tower is sent to the carrier location database. But in some countries like US and Japan, they made an additional requirement to all phone providers that, hey, instead of sending cell tower, the phone must send additionally a GPS receiver, a GPS location. And that's the picture. You see that there is a GPS location in some countries. Like this second connection is only in some countries, which is, for now, it's only GPS, USA and Japan. It goes through the selective router again and follows the same path. The same path so it goes through the carrier location database. Again, to the public safety answering point and dispatch center, and then again sent to the police department or to the ambulance or to the hospital. So for now, let's discuss on how location is computed today in this legacy system. We said there are two legacy systems we talked about. One of them is when you call a landline, and this is you see the flow, and from a phone. Most of the time, it's a cell tower location, follow the same route to the selective router and to the PSAP center. And this GPS upper path is only in 2 countries for today. That's the legacy system, what exists today. So in this legacy system, there are 2 main location methods. Phase 1 and phase 2. In the first slide, I will talk about phase 1. In phase 1, the location that is generally sent is not considered a dispatchable location. Phase 1, the location in the civic address or the nearest cell tower. So we get either a number coming from the landline number when you bought the landline, or a cell tower location. Both are very terrible locations, which is normally it's the centroid of the cell if you are doing a cellular. And as noted earlier, cell tower position range from hundreds of meters to kilometers in size. And you see the circle here. This is the accuracy of a cellular cell tower. So look at this, how many houses and areas and streets is the user who call 911 can be. So this means when you call 911, the user who call 911 with today's system, the ambulance will get a notification, hey, by the way, the location is the center of this circle, but we don't know. The user can be anywhere within the circle, and that's not very good. In phase 2, we said it's a two-phase process. The carriers use GPS location along with cell tower location when GPS is not available. And as everyone knows, that GPS is very accurate in open sky environment. When you're on very open sky, that's good enough. Again, this is only in US and Japan. In very open sky, no problem. And here you see, like, normally they prefer GPS. If there is no GPS, they send the cell tower. And normally the accuracy of GPS is much better than cellular. So what are the issues with phase 2 location? Can any of you think why this is still a problem, even if we send, like if we send GPS and cellular to this center and they send it to the ambulance or the police? Why this is still problematic? Because I mentioned at the beginning of the talk that many people call 911 while they're in this room. And this is not accurate in this case. As promised, I will splash few quotes during this talk. So here is another quote. There are times when the location doesn't come up at all. And actually, this is a quote from a chief of technology of one of these PSAP centers. We talked to them and they're complaining. He said, sometimes we get the 911 call, location is not showing up. Why? Again, because maybe someone called 911 while they're deep indoor. No location is possible to compute. And every day we receive a lot of cellular tower location with kilometers of accuracy. And this is a real statement coming from one of these centers operators. And here is the statement. As I mentioned, we often don't get location, and if we get it, it's a cellular location that is very inaccurate. So the FCC, which is a big organization in US, made the mandate because they see the problem. And they said, oh, this is not helping. We are losing life. We need to save life. So they made a mandate. In 2016, they issued a new set of regulation, and they referred to it as the fourth report and order. What did they order? They ordered wireless operators. Means anyone who is selling a phone, they need to have this mandate. They need to follow this regulation. What happens if they don't follow these regulations? They will need to pay money. If they operate in US and your phone doesn't follow this regulation, they will have to pay a lot of money to the FCC. And this mandate is related to, they call it the E911 mandate. And the mandate is as follows. They said by 2016, 40% of locations computed by any phone should have at max 50 meter in accuracy. By 2017, 50%, instead of 40, we have 50, of all location must be within the 50 meter. But they added one more requirement. They said, additionally, if the phone has a barometric sensor, and barometric sensor measure pressure, and from pressure you can compute altitude. If the phone has a barometric pressure, that pressure value should be sent to the center, because often you call 911 while you are in some floor in a building, right? And that's important to, so they added this mandate. If the phone has a barometric sensor, the information should be sent. By 2019, they make it more strict, and they said 70% of the location are within 50 meters. 2020, they increased it to 80 of the location should be within 50 meters, but they added another requirement. They said 50% of the locations should be should be able to send Z, which is the altitude. 50% of the computed locations by any phone operating in US should send altitude. Actually, they were not so strict. They say at least in 25 cities. Or they don't require it in all cities. They say in 25 cities in US. In 2022, the requirement was, they didn't add accuracy, but they say 100% of any location computed within US must have a Z, which is altitude, associated to it. Why? There are a lot of buildings with high floors. People call 911, and we don't know in which floor you are. And imagine, you don't want the ambulance to start searching the whole building, right? And actually, I'm happy to note that Google participated in this FCC test bed they had, and found that our position accuracy today exceed the 2022 requirement already. So how did we do this? We did this by building what we refer to as emergency location system, as I mentioned earlier, or ELS as an abbreviation. So let's see how ELS works. We are able to send our enhanced location, computed directly from the device, to the emergency service provider without any user interaction. How do we do it? We use something called fused location provider. And GPS work good outdoor. Indoor, there are other solutions. If I know you are connected to a Wi-Fi sitting there, I know where you are by seeing how the signal strength, how strong the signal that you are talking to that Wi-Fi. So if I measure, of course, assuming that I know where the Wi-Fi access point is. So we solve the problem by first finding where all the Wi-Fi access points in the world. We have a huge database. We compute all the Wi-Fi access point locations in the world. We run a pipeline to refresh that positions of all the Wi-Fi access points in the world. It's a huge monster pipeline, runs every Monday, finished by Thursday. It crunches data from many phones around the world. The final goal is, say, I have a database finding every access point in the world, where is it? And I use that. Now let's say now I have the knowledge of where the access points are. Now Tariq is connected to access point number 5. I know where that access point is, and it's, the signal strength measured by the phone is some number. Based on that, I will say, okay, this is so weak, means he is far away from that access point. And assume you have few access points around you. You can do triangulation to find where the user is. That's only Wi-Fi. There are many other sensors that could be used to compute to help GPS. Of course, in open sky environment, GPS is good. When we go indoor, we need these sensors. Wi-Fi, your phone has something called accelerometer and gyroscope. Why those are made? They are not made for location, but we use them. When you have a picture, when you have your phone and you turn it, the picture turns, right? They use this accelerometer and gyroscope. If you integrate acceleration, you will get speed. If you integrate speed, you get distance. Distance is location related, and other sensors. So we combine all these sensors to compute a location indoor in these challenging environments. Our system, as mentioned here, it just works. When someone calls 911, there are no updates required because we run it as a service in your Android phone, which means the updates come automatically. You don't need to click accept update. No special hardware needed. You don't need to put anything in the phone. No apps are needed because it runs as a service in the back end. It is supported on nearly all Android phones in the market today. It is simple to integrate with emergency responders. We just send location for any 911 call. And at Google, we believe this should be free service. We don't charge for it, since we want to do the most for our user during this life and death situations. So where we are today with regards to our service, and you see the stats on the right side there, we compute over 1 million locations daily using this system. ELS is currently live in 50+ countries. It's not an automatic enrollment like the Civil Defense Center in Saudi Arabia need to work with us to send location to them that they could send it to police. and so on. So every country needs to work with us to get that location. Today, we are live in 50+ countries, serving billion people around the world, and we are involved in 1.2 million emergency location calls daily. So every day, 1.2 million emergency location calls get location from the system and send to centers. I explained this before this slide comes, but I can summarize it again. How do we compute this accurate location? The ELS computed location is the same location that's used today by Google Maps. And now if any of you turn Google Map here, you will see the location already tells you are inside the building. This uses the same technology that, and the same location will be sent to the emergency provider. And by the way, not only Google Maps use that location. We made it public. So when we computed this improved location using all these sensors, we said there is no strong reason to keep it for us only, because many apps that use this location can improve user experience. Facebook, Uber, all these users want a better location to serve you better. So we made a public API, and they're using it. And in Android, our engine, as I mentioned, is called the Fuse Location Provider, FLP. If any of you has any experience developing apps, go to Google, search Fuse Location Provider API. You will see an API, and it gives you and when you call this API, you have the ability to say, I want the location to be very accurate, or I want less accuracy location. For example, if you are building a weather app to tell the weather in the area. Do you need a very accurate location? You don't need to, right? If I know roughly my location accuracy within a kilometer, it's good enough. Why you care as an app developer? Because sensors running consume power, right? So again, an advice that everyday story we see at Google, app developers build apps that are not user battery friendly. And you go as a user and you download these apps without knowing that this is not a very good app because it sucks your battery. By the end of the day, your battery is gone, and you complain and you say, X phone is bad because it is not, the battery is not good. And often it's you downloading an app that is not very well. We are doing, you can tell me, yes, you guys should do better job by validating the apps. And we are working on that. So our Fuse location provider combines, as I mentioned, GNSS, cellular, Wi-Fi, accelerometer, gyroscope, barometers to get the most accurate location for all of us. And any of you, if you now turn your Google map, you will see the location most probably will be inside this venue because, of course, we know where all the access points, the Wi-Fi access points here in this building are. Are we done yet at Google? The answer is no, because indoor location is a very challenging problem. And our goal is to achieve 5 meters. Like this is our short-term goal. Of course, the more accurate, the better. Why 5 meters as a goal? Because for us, 5 meters is a shop area. If you are in a McDonald's and you know what is on average, McDonald's area is 5 meters. And that's the first goal. I want to know in which shop the user is. Next level, if I can achieve 1 meter, of course, I will know in which aisle in a supermarket you are. And that's very important. If I can know the user is next to which aisle, I can provide impressive stats, and to the shop owner, they can say, hey, users are, most of the time, are next to this aisle. They like this material. Let me put it in a very visible. So we all want to make money, right? We don't want to, it's not only 911 use case. But of course, 911 will benefit from this. Have you noticed your phone location getting better and better inside malls, indoor areas, over the last few years? I think the answer is yes, and you are not imagining it. Because we continue to improve our Fuse location provider, we add machine learning, like all of us. Everyone wants to do machine learning. We do machine learning. And with each release of the Fuse location provider, importance of this Fuse location provider, it's a service run in the back end. You don't need to accept anything. As long as you have Wi-Fi, the latest algorithm we have comes to your phone. And we steadily make improvements using machine learning, as I said, and so on. And for the future, we are very looking forward if you heard about RTT technology, which is a round-trip delay, many of the newest Wi-Fi standards, starting from 802.11mc, Wi-Fi is normally made for communication, but this newer standard has additional technology made for location. It's supposed to make location much more accurate. Why? Because it will not use the signal strength. We will use how long the signal went from your phone to the Wi-Fi access point and come back. Why we cannot do this today? Because we don't know how long the signal gets processed in the Wi-Fi access point. If it takes one Wi-Fi access point will take 3 seconds, another will take 2 seconds or less milliseconds. This delay, if we don't know it, you will not be able to use this technology to compute location. So in the new standard, every access point is supposed to tell how long it took it to process the data. And with that, we can use round-trip delay, and that's supposed to bring our accuracy to meter level. And that development is still going. And we hope, like many of the new Wi-Fi access points, already support the technology. And we have a dashboard back there. We monitor the penetration of this. So we expect in a couple of years, we will see a lot of Wi-Fi access points with this technology, and we can do meter-level indoor location. OK, let's walk through in details how ELS works. First step, a user dial an emergency number, 911, 112, 111, and trigger automatically in the phone. We have a service running in the back end, and it detects if anyone dial this number, the service gets triggered. Once ELS is started and triggered, it will invoke the fused location provider that I explained, which we just spoke about. Let me take a second here, because I was asked to say this. Privacy is very important of what we do. Because when we are in emergency, we need to override some of the settings in the phone. Sometimes you go in the setting and you say, don't use my location. Don't allow anyone to use my location. In 9111, we override that setting because it's a 911 setting to be able to compute a location. But then, when the ELS service ends, when the call finished, we bring back the settings to the default what you had earlier, and we make sure this location computed doesn't go to what we refer to as user plane. We have user plane and control plane. Control plane is anything goes between the phone and the telecom provider. So no app running in your phone will have access to this location. It's only through a channel going to the telecom provider, not stored in the phone at all. So no one will have access to it. Once the location is computed, we format the ELS message, then goes out to partner provider, to the PSAP centers. The message goes directly from the handset to our partner endpoints with no location ever going back to Google. The ELS message is a simple message, very simple message. It contains latitude, longitude, and timestamp, and very important, the accuracy. If we send the location, say that's accurate, this means the ambulance will really know, I don't need to search, I know the user is in this location. The partners are then able to route our enhanced location directly to the PSAP center, Public Safety Answering Point Center, who is then able to dispatch police, fire, or ambulance to the emergency. Let me summarize how ELS works. Simply, it just works. The user doesn't have to do anything. It's built into the core Android system. Support is baked in almost 100% of Android handsets in the market today. It has to be enabled with one of our partners, and that's important. And good news for all of you, it's already enabled in Saudi Arabia. We work with civil authority here, and its location is sent already. So we partner with country governments, carriers, and emergency service providers. It's a complex process because it's not a single entity for each country. Each country has its own entity. So one of you might wonder, why didn't we go through the old system, the legacy system, and modify it instead of sending cellular location and GPS. If you remember the first slides when I explained the legacy system, why don't we modify that system to send now a fused location? We started this process, but these governmental regulation-related authorities are the slowest ever. So they told us it will take years, and emergency cannot wait for years. So we had to invent this side channel to send this location for the 911 centers until that slow train catch up. So locations are computed directly on the Android handset and sent directly to the emergency operators. And lastly, we provide this service for free because we want to do everything to better protect our user during these emergency situations. Just to show you the value, I have a couple of success stories to tell you. Now I promise there are much more because we already launched a few years now, but these are like some of the early success stories. And if you allow me, I will just read them directly from here. So the first success story came from Estonia. There was an emergency from a child home alone. The child was alone in the house, who told emergency operators that their toaster oven was on fire. Unfortunately, the child didn't know their exact address. They knew the street name and the flat number, but not the complete address. The call taker used the location information she received from ALS and found the right house to be able to dispatch the fire department, who put out the fire quickly. If you look at this image, I have two circles there. One circle, the cell tower legacy system, was with an uncertainty of 120 meters. Because this PSAP center, they anyhow get the legacy system data, which is cellular or GPS only in US and Japan, as I mentioned. But through an additional channel, they get our new location. So they have the two locations in front of them. And we ask them, because they are our early users, we ask them to send us both locations for the success story. And they send us, they say, hey, in the legacy system, we get an accuracy of 120 meters. With your new information, we get an accuracy of 30 meters. 30 meters is still, now we are much better. But anyhow, look, we reduced the search area for this emergency situation by very noticeably, and allowed the fire department to really reach the user in need fast. One more success story. An 8-year-old boy reported that had found their father unconscious or dead. They didn't know. They're 8-year-old. The 8-year-old didn't know the address. The operator asked about the address. They didn't know. The cell location was received by the legacy system, and it had a cell radius of 14 kilometers. Cell location can be bad because if you are in a very crowded place, they install many cellular towers, and then the accuracy becomes based on the cellular tower density. But imagine you are in a suburb. They don't need many cellular towers, so one cell tower can cover a large area. And here is an example, 14 kilometers. But ELS location was sent with a radius of 6 meters. And it was spot on the house. The emergency responders were able to go to the correct location and save the boy's father. One more success story of today. So let's go to the Alps in Austria, out in the middle of nowhere, actually. This is in the Alps, with no landmarks around, which is today many operators, when someone call 911 and I don't know where they are, they ask, what is next to you? And then you can say, next to me is this shop or this building. In this situation, it's in the middle of nowhere, no landmarks. Again, remember, in Europe, it's not required to send GPS. GPS, we say, is only in Japan and US. In Europe, they send only cellular location. So the cellular location is sent to the center. A mountain biker suffered a serious accident while riding in this heavy forested area. That's the story. He was able to place an emergency call. So he called the 911 or 112 in Europe, but there was no landmarks inside for him to give to the call taker. The cell location delivered had a radius of almost 1 kilometer in size. ELS was able to deliver a location of 12 meters. 12 meters is perfect in an open. Here, why GPS is not perfect? Anyhow, in Europe, GPS is not required. But under trees, GPS also doesn't perform perfectly. So with our system, we got 12 meters, and this guided the emergency responders to the exact scene of the accident, and again, saving lives. One thing I would like to mention here, based on all these success stories, we have recently received a lot of press, like TV, media, because when there are such stories, media get to know. Especially with our we extended the service now to many more countries, and with the recent extension, so I thought I would share a short clip highlighting one of the media coverages.
This could really save lives. If you ever have to call 911 from an iPhone or an Android device, dispatchers are now much better able to pinpoint where you are and send you help faster. The cell phone device, as well as service providers, have improved location finding abilities if you're dialing 911 in the event of an emergency. 4 in Your Corner's Carl Fortier is in Collier County, showing you how the technology already helped one woman in an emergency. Carl?
Well, none of us wants to ever have to call 911, but it's likely we will at some point in our lives. And if you're disoriented and can't tell dispatchers where you are, your smartphone can tell them for you.
When you call 911, your phone knows it's calling 911, your phone knows the location, and it can then send that to our 911 call taker.
These Collier County dispatchers are now able to send you help faster if you have to call 911 and you're calling from an iPhone or Android. iPhone users will have to first download the latest iOS update, which is iOS 12. Google announced today it also uses a device-based location service enabled on Android phones. The Collier Sheriff's Communications Director says the ability to find people who need help by pinpointing their smartphones is an exciting advancement for first responders.
People misstate their location. They don't know where they are. You know, in Southwest Florida, we have a lot of visitors to the area. But the most important thing in calling 911 is knowing where the emergency is, because then we can get help started, regardless of anything else.
He says at least one recent call has already proven the value of the technology when she called for shortness of breath and said she was at Fresh Market.
That's what we heard. The caller said, Fresh Market? Okay, let me transfer you over to the city. So we transferred the call over to the city's dispatch center. She was actually at Whole Foods.
Did any of you hear iPhone? I don't work for Apple, right? So what we did after building this technology, this is a life-saving experience. So we have channels to talk to the people across the road, to the fruit company, and we work together, and they have the same sensors in their phones, right? We work together. We spent a few months working together, and they launched the same service in iPhone. And that was a good example of a cooperation between two enemies for the saving people's lives. As I promised, I will mention more quotes until the end. And here is one more quote, a very important quote actually, which is about estimating a very wrong location. So while we are doing some tests with British Telecom, we got this feedback, which is estimating a very wrong location can be worse than not estimating a location. And that's important. So our system, we did a lot of tests to make sure the accuracy should be important, or the location shouldn't be wrong. If we are not sure, we better don't provide the location, or make sure to provide with good accuracy. So it's still, the good thing about this topic or this area of work or location technologies in general, it's in production, but it still has research. Like the problem is not yet solved, which allow space for many groups and researchers like Professor Tariq to do research in the area and help improve the accuracy. So at the beginning of the talk, if you remember, you saw a short clip on how our emergency system is failing us today by estimating wrong location. And you remember the location was across the bridge. Here is another call, very similar to the first one, same location in Miami, But this time, let's see what would happen if we use ELS location instead of the location we sent. In this video, you will see one of our team members again, calling 911 again. They know it's a test call. They will not send ambulance. But this time, pay close attention to the red dot that appears on the screen. This is showing an ELS location received if the service was enabled, and also pay attention to how quickly the location is delivered, just seconds after the call is placed. The operator didn't even get a chance to say a word, yet the location was already there. So let's play the clip.
Hi, this is a Google test call. Can you please tell me the address on your screen?
800 Brickell Avenue.
And can you repeat that one more time?
Yes, 800 Brickell Avenue.
Excellent. Thank you very much.
Again, the location below, this is what we have today. The top is the ELS location, and now the ELS location is really on the spot of where the call were made. And whatever we send to the operator, we tell them what is the source. You see the source is Wi-Fi. We are just telling them some extra metadata to the operator. Hey, by the way, this location is computing using Wi-Fi signals. Again, as I said, the legacy system sent a cellular towel with 500-meter accuracy, or 500 meters away from the accurate location, but the ELS location was on the spot, placing us in the right location if there is an emergency situation. The final quote for today that I would like to leave you with is, the FCC itself states that in the US, 10,000 lives could be saved each year if the emergency dispatching systems could get to you 1 minute sooner. 1 minute sooner in the whole US statistics, 10,000 lives more could be saved. To conclude this talk for today, our life can change in a split of a second. We feel it's our duty to help our users during these stressful emergency, life and death situations. ELS is here and is ready today, exceeding the FCC regulation that are set for 2022. We do this through our fused location provider, FLP, that we talked about, fusing a lot of data from many sensors. Still, if we want to reach the 1 meter accuracy, which we are not today, we are not yet even 5 meters, all the time, seamlessly, indoor and outdoor and in urban canyons in the middle of very high buildings, we need to fuse data using the fuse sensor provider, and we need a research group to help us do more in this. Of course, we don't use only location, we use sensors, we use activity recognition, and we need, the location need to continue getting better and better and as we come together. Because the end goal is to bring better context and more location accuracy, again, at the lowest power. You don't want, when you need to call 911, your phone is out of battery. So we care a lot about battery, which will lead to better user experience, especially when we need it most during emergency situations. With this, I would like to thank all of you for listening, and a special thanks to Professor Tarek and the WEP for the invite. One more thing I would like to leave you with. This is just an inspiring video based on a true story. It will take a minute or two for running. I will leave, but I will let you running with the video, or I will wait for questions.
Ich bin fast täglich mit Situationen konfrontiert, wo man Leute sucht. Es können Leute sein, die auffindbar sind. Und wenn man keine Koordinaten hat, die dann zu finden, ist unmöglich und eigentlich nur auf einen Zufall oft zurückzuführen.
Ich hatte gerade einen kleineren Unfall. Ich verstehe dich ganz schlecht. Hallo? Hallo?
Ich habe die Information erhalten, dass ein Paragleiter abgestürzt ist. Ohne weitere Angaben wäre es ein stundenlanger Aufwand gewesen, diese Person zu suchen.
Das heißt, es kann vorkommen, dass es am Tag sehr warm ist. Sobald die Sonne weg ist, wird es eiskalt. Wenn dann die Personen nicht richtig ausgerüstet sind.
Many of us carry a smartphone with very accurate location technology, but we realized in an emergency that location wasn't being sent to emergency responders. We saw an opportunity to help a lot of people.
Im Fall von Andy und wenige Sekunden darauf habe er schon von dieser neuen Technologie seinen Standort mitgeteilt bekommen, die Position auf 6 Meter genau.
Der Moment, in dem man erkennt, man konnte jetzt jemandem helfen, der ist eigentlich unbeschreiblich, weil das der Sinn des Ganzen ist. Und das eigentlich der Grund ist, warum man das Ganze macht, warum man selber ein gewisses Risiko eingeht.
Sorry, and thank you again.
Thank you very much, Dr. Khider, for a very inspiring talk. Unfortunately, we're out of time. I myself had lots of questions. I'm sure the audience has lots of questions. The good news is Dr. Khider is with us today. He's also with us tomorrow for a full workshop on using Android's API tools for location services. So you're welcome to talk to him after the talk right now for the rest of the day and tomorrow. Thank you again.
Everybody, just a quick thing before you leave. Just a reminder that the keynote lecture is today at 5:30, so please remember to come back here. It's going to be a great one.